Today's lesson is going to ask us to solve systems of equations by substitution again. The difference here is that we're going to make sure that when we substitute, we've got to remember to multiply by the coefficient that's in front of the variable. So let's take a look at the problems that we're going to end up seeing. First one here, we've got x by itself. So use this method of substitution when we've already got a variable isolated. Here we do. And so we're going to take this expression that x is, this 7 minus 2y, and we're going to put that in place of x in the equation below. So we're going to rewrite that bottom equation, but in place of that x, I'm going to write the expression that x is, which is 7 minus 2y. And then I'll bring down this plus y, and this equals 5. Well, from that point, we need to distribute. We need to distribute this 2 over 7 and 2 over the negative 2y. And so when we do that, we now have 14 minus 4y plus y, and this all equals 5. Well, from that point, we need to do some opposite operations and collect like terms. So let's do this first. This is a positive 14. We need to take it away from both sides. So again, when you're going from one side of the equal sign to the other side, that's when you use opposite operations. We can also collect like terms on the same side. So when they're on the same side, you're just collecting. If they're opposite signs like they are, then we will subtract. And we'll end up with, in this case, negative 3y equaling, and then subtract these two numbers because they're opposite in sign, negative 9. So from this point, we need to do a division problem. We're going to divide by negative 3. And so now we've got y all by itself. Y equals 3. So from this point, we can now find out what x is by doing another substitution problem. And so we're going to take this 3 and put it all the way back up here, and for y in that top equation. That would be the easiest equation to substitute into. So we end up with x equaling 7 minus 2 times by 3. So we go ahead and do some work there. We've got x now equals 7 minus 6, which is just 1. So there's our answer. It is 1, 3. That's the point where the two lines end up intersecting. Well, a couple more examples similar to that. Here's another one where this time y is by itself. So I'm going to take the expression that y is, negative 3x plus 4, and I'm going to put it in place of y in the equation below. So we can rewrite our equation. This time we can rewrite the bottom equation as x minus 2. Now, since this negative 2 is being multiplied by y, I need to make sure parentheses go around the expression that y is, which is negative 3x plus 4. Again, it says y equals negative 3x plus 4, so that needs to be placed in place of y. Well, from that point, we can go ahead and close the parentheses and bring down the equal sign and the 6. So from this point, we can distribute now the negative 2 over that addition. So what we've got left is just this x plus 6x minus 8 equals 6. So notice that the negative times the negative made a positive 6x. Negative times a positive made a negative 8. Well, from that point, we can go ahead and do an opposite operation. Again, we're on the same side of the equal sign. We combine opposite sides. We do an opposite operation. So we're going to add 8 to both sides. Also collect some like terms. It's a positive x, positive 6x. And we need to combine those to make a positive 7x. So that's what we've got. So 7x now equals 14. Well, one more step here, and that is to get rid of this 7. We get rid of that by dividing by 7 on both sides, and we'll have our answer. So now we've got x equals 2. Well, that's the x value. We still need to find y, so what we do is take that 2 and put it way up here in for x in the top equation. It's best to always use the equation that the variable is already solved for. And so this time it's the top equation. So we have y equals -3, but in place of x, we're going to put 2 and then add the 4. And so we go ahead and do some work there. And now we've got this. Y equals -6 plus 4. And so from that point, we could go ahead and collect, and we've got now y equaling -2. So our answer is going to be an ordered pair. It's 2, -2. And that is it. Well, we've got another problem here. And this one is one where we've got y by itself, again, just like the last problem. So we're going to take the expression that y is, which is 3x minus 11, and that expression needs to go in place of y in that bottom equation. So let's go ahead and rewrite what we've got. We've got a 5 times by y. Well, y is 3x minus 11, and then a minus 7x equals 1. Well, same as before. We just use that distributive property. Eliminate those parentheses. Distribute the 5 over that difference. So when we do that, we now have 15x minus 55 minus 7x equals 1. So again, when we're on the same side of the equal sign, we can collect, but opposite sides of the equal sign is when we do opposite operations. So that's a minus 55, so I'm going to add 55 to both sides. I'm also going to collect these like terms right here. Watching the sign, you always got to look at the sign in front of the term. So that means I need to subtract those two values there. So I end up with an 8x equals, and then I add those two numbers, I get 56. Well, from that point, we could go ahead and do some division and divide by 8. And 8 goes into 56, grand total of 7 times. So 7 is the value of x. And now we're ready to do our final substitution. We've got to take that 7, and we put it way up here in place of x. And we'll find out our y values. So we go ahead and write down y equals, and we've got 3 times by 7, and then minus 11. So we'll go ahead and do some more multiplication and then some subtraction. So we have y equals 21 minus 11, which gives us 10. And there we've got it, our answer. Our ordered pair, it goes in alphabetical order. So remember, x and then y. So we write down 7 and then 10. So 7, 10 is the answer for the third one. Well, that's the first part of the homework. We'll take a look at the second part and probably solve some equations and writing equations as well.